Hello everyone and welcome back to another video. In this video I'll be going over the problem generate parentheses. I'll be explaining what the problem is asking, the solution behind it, and then talking about how to implement the solution. So in this problem you are given an integer which represent how many pairs of parentheses you have. So a pair of parentheses, sorry, I forgot to erase this from the previous video. So a pair of parentheses would be just one opening bracket and one closing bracket. So with n pairs, you have to generate all the combinations of well-formed parentheses. So with 3 pairs of parentheses, we'll notice we have 3 opening brackets and 3 closing brackets. And well-formed parentheses just means that for every opening bracket, we'll also have a closing bracket. So, for example, this is a well-formed parentheses, this is not well-formed, obviously, and something like this, this is not well-formed either, and yeah. So basically, for every closing bracket that you run into, you must have a previous bracket that is opening to be able to keep this a well-formed parentheses. So yeah, and since you have 3 pairs here, these are all the possibilities that result in permuting these 3 pairs that keep all the parentheses well formed. And n is between 1 and 8. So now let's get into the solution. So because n is so small, it's between 1 and 8, we can actually just use brute force here. Because since there's at most 8 pairs, we know that our final length of the string can be at most length 16 because each pair will be 2 of these parentheses, right? And so if at each index you can either have an opening bracket or closing bracket, then you will have 2 to the 16 total possibilities to check. And if we do the math here, 2 to the 16, that's only 65,000. So we know that's easily enough to just be able to brute force it out and check all the possibilities, because we're only going to be checking 65,000 possibilities, which for a computer is extremely easy. So now let's just look at how we can generate this. So essentially we can just have a function that will keep track of our current string and how many more numbers, how long the string needs to be. And so if our current string is, let's just say we have a n equals 2, so our string length will be 4 because we'll have 2 pairs of parentheses, multiply that by 2, we have 4. And so we know our answers here in our output array will be of length 4 when n is equal to 2. So we can just have a function that we'll pass in 4 into and a string. And if that string is of length 4, which is our base case, we will just return the string. So it'll be some random thing here. For example, this is a potential string. Otherwise, we will add this to our string here. Like, let's just call our string current. We will add this to our string here, and we will call our function again, but we'll also pass in 4, of course, and we'll call our function again, but it looks like this, and then we'll call our function again with this possibility to represent both options of writing a opening bracket here or a closing bracket here. So in the end, we'll generate strings that kind of look like this. So we will start off with our current string being empty. We will explore a possibility of adding an opening bracket to it and adding a closing bracket to it. And then we will, for both of these possibilities, since we're calling this recursively, we will do the same thing where we generate this and then this, and of course like this, and so on until we have until the height of this sort of exploration will result in us having 4 characters. So we'll have something that looks like this, and then we'll have a case that looks like this, and then so on. And once we have all of these strings, we can simply just check them to see if they are a valid parentheses. The way we can check them is simply just by starting from the front and keeping a integer that tracks how many opening brackets we have. So whenever we run into a situation where we have more closing brackets than opening brackets, we know this is false. We can return false because this will never be a well-formed parentheses, because since we're just looking for the characters afterward, we know that there's no way to match this closing bracket with anything. And similarly, once we get to the end, we just need to check if our opening brackets are equal to 0. So that means for every opening bracket, we have found a matching closing bracket to pair it with. So yeah, so now that we know the intuition behind the solution, let's look at how that's implemented. So we will have a list of strings, which is going to be our answer. When we call this method with the initial n, we will just create a new array list, which is the thing we're going to return. And we're just going to call our recursive function. This is how long the string needs to be, and this is the current string we have built up. So yeah, so it looks like I actually implemented it a slightly different way than I explained in my solution, but it still works. So we will instead of checking if the length of our current string is equal to n, we'll just decrement n by 1 every time here, and so we can just check when n is equal to 0. They're equivalent logic. So in our function, the recursive part is we will take what we have so far, add a closing bracket to it, and subtract 1 from the number of elements we have left to add. Then we will do the same thing but with the opening bracket and subtract 1 from the number of elements we have to add. And when there are no more elements we have to add, we can check if it is well formed, and if it is, we can add that permutation as a possibility, as an answer in our list. Otherwise, we can just, and after that we can just return, and if this is not well formed, we'll just return. So this function here will test if a string is well formed, and this is exactly what we talked about. We just have a variable here. This represents the number of opening brackets we have encountered so far. And then for we iterate through the indexes of our string. And if it is a closing bracket, we will check if there's an opening bracket to pair it with. If there's an opening bracket to pair it with, we will decrement 1 from the number of opening brackets we have left to pair. If there are no opening brackets left to pair it with, we will return false, because there is no way to complete to make this sort of structure a well-formed parentheses, because we can't just add another opening bracket there. And otherwise, if we encounter an opening bracket, we will just increment the number of opening brackets that we have by 1. At the end, we will return if all of our opening brackets have been matched with a closing bracket. So if we have way too many opening brackets, then we know we want to return false. So yeah, so then after all this is all done, we can just return what we have added to our list. And so let's just submit this to show that it works, and it's accepted. So the runtime of this will be 2 to the n, because we will have to essentially check 2 to the n possibilities, and checking them is a n operation. So this would be n times 2 to the n. That's the final runtime of this solution. So that's about it for this video. I hope you enjoyed, and thank you very much for watching.